Ever pondered how we describe the motion of objects? How we can predict where a thrown ball will land or how fast a car must travel to reach its destination on time? Four core concepts in physics provide the answers: displacement, velocity, acceleration, and force. Displacement is our starting point. As the term suggests, it refers to the shift in an object's position from where it began to where it ends up. It's a vector quantity, meaning it's got both magnitude and direction. Imagine a sprinter running a 100-meter race. The magnitude of displacement is the 100-meter distance from the starting line to the finish line, while the direction is the path the sprinter takes. Next on our agenda is velocity. This is the rate at which displacement changes. Also a vector quantity, velocity is measured in meters per second. The speed of an object is the magnitude of velocity, which is the distance traveled over time. The direction of velocity, like displacement, is the path of motion. Acceleration takes us a step further. It's the rate at which velocity changes and, you guessed it, it's also a vector quantity, measured in meters per second squared. The direction of acceleration is the direction in which velocity is changing. Picture a car speeding up to overtake another. The car is accelerating in the direction it's moving. Finally, we come to force. This is the interaction that causes an object to accelerate. Force is measured in newtons and it equals the mass of an object multiplied by its acceleration. Think about pushing a stalled car. Your push is the force causing the car to accelerate. These four concepts connect through various equations. Displacement is given by the equation delta x equals v0t plus half at squared, where delta x is the displacement, v0 is the initial velocity, a is acceleration and t is time. Velocity is calculated by the equation v equals v0 plus at, where v is the final velocity. Acceleration is found using the equation a equals delta v over t, where delta v is the change in velocity. By understanding these concepts and equations, we can describe and predict the motion of objects, whether it's a ball thrown in the air or a car on a highway. We've unlocked the language of motion: displacement, velocity, acceleration, and force.